Which of these square numbers also happens to be the sum of two smaller square numbers? 16, 25, 36, 49.
This is hard to do math when you're sitting up here.
Ryan, take your time, okay? You have a lot of time.
I'm trying to think here. You know, it's under a lot of pressure right now. I'm going to ask the audience.
No problem. Audience, Ryan really needs your help here. If you're ready, vote now. Okay, 50% believe it is 16, 30% say 25, and 19 for 36, and just 1% for 49. Let's check with the AOL Instant Messenger crowd. 45% of them say 16, 23 for 36, 22 for 25, just 10% for 49.
I'm going to go with the audience on this, and I'm going to say A, final answer.
Oh, Ryan, the audience is not right. I'm sorry. It was B. It was 4 squared plus 3 squared is 16 plus 9.
Where do all of the binomials come from? What happens when we are all given two different binomials to multiply together? For example, x plus 4 and x plus 2, or x minus 5 times x plus 3. I want you to pause this video and multiply these binomials together on a separate sheet of paper. The result, you should get a trinomial, and more specifically a quadratic, because the degree of the leading term is 2, and when you have a degree of 2 with a trinomial, it's considered a quadratic equation. So you get x squared plus 6x plus 8, and you get x squared minus 2x minus 15. So I have a question for you. But what if I give you the trinomial or the quadratic and ask you to find the binomials that multiply to get back to the trinomial? How would you do that? I want you to try this. Yes. I want you to ponder and really think about it. Look at the patterns that you see. How do we get the x term? How do we get the constant? Take a minute and write down your findings. What patterns, what discoveries did you make? Pause this video and actually look at the quadratics and the product of the binomials and tell me what you see. So we're going to dive a little bit deeper into the transformation between the binomial product and the trinomial. So how on earth do we go from one to the other and back again? Working backwards. So if we just look at when we multiply the two binomials together, when we multiply the x's, we get x times x, which is x squared, which just happens to be the first term in our quadratic. That's kind of interesting. So we know that when we go from our quadratic back to our binomials, each binomial has to have an x in it somewhere. To get the last term from the binomials, we multiply the constants together. So we get 4 times 2. Well, 4 times 2 equals 8, which is our last term in our quadratic. So I wonder if there's a relationship there. And to get the middle term, we add the two x terms together. So we get 4x plus 2x. 4x plus 2x equals 6x, which is what was in our quadratic. I wonder if there's a relationship. 4 times 2 equals 8, but 4 plus 2 equals 6. And those just happen to be in our quadratic. Take a minute and pause the video, and see if you can find the relationship. In order to complete this, we have the necessity. We need to find two factors which add to the middle term and multiply to the product of the leading coefficient and the constant term. So for our case, we needed to multiply to 8 and add to 6. That's kind of interesting, as what we just saw on the previous slide. 4 times 2 is 8, and 4 plus 2 is 6. So there must be a relationship between the two, which is addition and multiplication. I want you to try one. I know it's hard, and I know it's something that's new, but I want you to try to use that pattern and factor out x squared plus 3x minus 18. Tomorrow in class, we will be going over this and getting more practice, but it is an expectation that you come to class with this problem attempted and tried. You will know if you get the right answer if the two constants multiply to negative 18 but add to 3. Today we did some hard stuff. We did something called factoring, and it's something that you've never seen before. We took a concept that you know pretty well, multiplying binomials, and we took the product and then we worked backwards. It kind of rocked your world. I understand that. Your expectation and your job today for class tomorrow is to complete the two examples that were used in the video. I would love to see what discoveries you made while you took the time to watch the video. You need to work out the problems, and then you need to do the last you try it problem at the very end. These are going to be done in class, and we are going to go over them in class. Tomorrow we will also have a lot more practice to do this, and so don't feel like you have to be perfect right now. However, I want you to attempt it. Even if you come with a list of questions tomorrow, that's better than nothing. I will see you tomorrow in class, friends. Isn't this so fun?